We always talk about how big the universe is. Let me tell you today how big a solar system
From
is.
years of experiments, research, and exploration, scientists have estimated that our observable universe, like the point up to which we can observe, our observable universe consists of 200 trillion galaxies, each galaxy with at least 100 billion stars, and each stars with at least 4 to 5 planets revolving around it. This all just sums up to normal matter that makes only 4% of our whole universe, and we don't even know what other things are. We say it's dark matter and dark energy, but today let's dive into a solar system. We know our solar system. We've been told about it since we were like little kids. In our solar system, we have the sun, 8 planets, their moons, some dwarf planets, asteroids, and some dust and icy objects. But is that all it? Well, no. Our solar system is 2 light years in diameter. When we go beyond Neptune, the objects found are called trans-Neptunian objects, TNOs, or also called Kuiper Belt objects, KBOs. The Kuiper Belt is a circumstellar disk which lies in the outer solar system beyond the Neptune. It is similar to the asteroid belt present between Mars and Jupiter, but 20 times larger than that. The objects in the Kuiper belt primarily consist of rocks, metals, and icy objects. Also, methane, ammonia, and water can be found in frozen state in the Kuiper belt. The Kuiper belt is home to most of the known dwarf planets like Haumea, Makemake, Pluto, etc. After the Kuiper belt comes the heliosphere. It is a bubble-like region of our solar system. The heliosphere is a region around the solar system in which our sun's solar winds have a significant impact. It is also called the outermost atmospheric layer of the sun. Due to the name heliosphere, we might confuse it for being a sphere, but the bubble of the heliosphere is continuously inflated by the plasma originating from the sun known as the solar winds. Outside the heliosphere, this solar plasma gives way to the interstellar plasma permeating the Milky Way. The total length of the heliosphere from the Sun to the heliopause varies, but it is generally estimated to be about 100 astronomical units. The heliosphere includes several regions in it. The solar wind region comes first and it extends outward from the Sun and gradually slows down. After the solar wind region, there comes the termination shock. After the termination shock comes the heliosheath, the region between the termination shock and the heliopause. And after the heliosheath, we have the heliopause, the boundary where the solar wind stops and the interstellar medium begins, around 100 astronomical units. So the distance from the Sun to the heliopause is typically considered to be around 100 astronomical units, but this distance can vary slightly depending on the solar activity and local interstellar environment. After the heliopause, there comes the Oort cloud, which is located outside the heliopause. The heliopause marks the boundary where the solar winds from the Sun slows and merges with the interstellar medium, while the Oort cloud is a theoretical region that is believed to extend from about 2000 to 100,000 astronomical units from the Sun. The Oort cloud is a very distant spherical shell of icy bodies believed to surround the solar system, serving as a source for long period comets. But the Oort cloud is thought to be beyond the reach of the solar wind and protective effects of the heliosphere, making it a part of the interstellar environment. So, now we know that the solar system does not end at Neptune, but it is way beyond that. And at the end of the video, I would want to say that there are known knowns, and there are known unknowns, and there are unknown unknowns. The universe is full of things we will never know.